Next question is the constructional features of a Pelton turbine. Okay, so this is from April 2018 question paper. You can refer April 2018 question paper. The question is explain the constructional features of a Pelton turbine. So the marks is actually 5 marks. So you have to write the constructional features of Pelton turbine and check the marks, 5 marks. So you will get 5 marks here. Okay, so I will explain. Okay, so the constructional features means what are the main parts of a Pelton turbine. That is very important. Okay, so the main 4 important parts are nozzle and flow regulating arrangement, or that is called a sphere. Then number 2 is runner and buckets. Number 3 is casing, and number 4 is braking jet. Okay, so these 4 are the main parts of a Pelton turbine. So this is very important in the constructional. When the question is asking like this, constructional features of Pelton turbine, so you have to write the main parts: nozzle and flow regulating arrangement or sphere, runner and buckets, then casing and braking jet. Okay, so Pelton wheel, about Pelton wheel or Pelton turbine, so it is actually a tangential flow impulse turbine. This term is very important. Tangential flow, different types of turbines. Pelton wheel or Pelton turbine is a tangential flow impulse turbine. Okay, then what do you mean by tangential flow impulse turbine? Okay, I will explain. So tangential flow means the water strikes the bucket along the tangent of the runner. Okay, so the water strikes the bucket. So I will show you a video. So this is a video from YouTube. You just go to YouTube and then search Pelton turbine animation. You will get this video. Okay, so you can see this is the runner. Okay, so I will play it. So you can see this rotating. This is the runner. Okay, and on the runner you can see different buckets. So this is called the buckets. These all are the buckets. Okay, so the water strikes the bucket along the tangent of the runner. You can see this is the water. This is the water, and this water strikes the buckets of the runner tangent to the runner. You can see the water strikes the bucket along the tangent of the runner. So it is called tangential flow turbine. Okay, so once again I will play. You can see the water. Okay, so you can see the water. So this is the water. This water strikes the bucket along the tangent of the runner. Then it is called a tangential flow turbine. Then impulse. There are another types of classification of turbine is impulse turbine and a reaction turbine. So Pelton wheel is actually an impulse turbine. So what do you mean by impulse turbine? So impulse turbine means the energy available at the inlet of the turbine is only kinetic energy. Okay, so the energy, so here the energy available at the inlet is kinetic energy. Then it is called, this turbine is called a impulse turbine. So Pelton wheel or Pelton turbine is actually tangential flow impulse turbine. Tangential flow impulse turbine. Okay, so tangential flow means the water strikes the water strikes the bucket along the tangent of the runner. It is called a tangential flow turbine. Impulse turbine means the energy available at the inlet of the turbine is only kinetic energy. So Pelton wheel or Pelton turbine is called a tangential flow impulse turbine. Okay, and about the pressure at the inlet and outlet of the turbine is atmospheric pressure. At the inlet and outlet, the pressure is atmospheric pressure. And this turbine is used for actually high heads. Okay, and is named after L.A. Pelton, an American engineer. So L.A. Pelton is actually discovered this Pelton turbine. Okay, this is used for high heads turbine. Okay, so once again the definition of Pelton wheel or Pelton turbine. Pelton turbine is actually tangential flow impulse turbine. Okay, then what do you mean by tangential flow? What do you mean by impulse turbine? Okay, then what about the pressure? The pressure at the inlet and outlet of the turbine is atmospheric, and this turbine is used for high heads. So these are the general thing about Pelton wheel or Pelton turbine. Then figure shows the layout of a hydroelectric power plant. Okay, so here you can see this is the layout of a hydroelectric power plant. So you know what do you mean by hydroelectric power plant. So you can say this is the dam, and this is the penstock. Penstock means the large diameter pipe, and this is the turbine. Okay, so the layout of a hydroelectric power plant in which the turbine is Pelton wheel. So here this turbine is actually Pelton wheel. You can see this is the runner, and this is the buckets. This is the buckets or vanes or blades. Okay, the water from the reservoir. So this is the reservoir. See this portion is the reservoir. The water from the reservoir flows through the penstocks. Penstocks means this is the penstocks. You can see penstock means large diameter pipe. So this is the reservoir and this is the large diameter pipe called the penstocks. Okay. At the outlet of which a nozzle is fitted. So here you can see a nozzle is there. So this is the nozzle. Okay, a nozzle is fitted. Okay, then the nozzle increases the kinetic energy of the water flowing through the penstock. So this nozzle increases. This is the nozzle. This nozzle is actually increases the kinetic energy of the water flowing through the penstock. At the outlet of the nozzle, so you can see this is the outlet. This is the outlet of the nozzle. At the outlet of the nozzle, the water comes out in the form of a jet. Okay, so here, so at the outlet of the nozzle you will get a jet. Okay, jet of water. You will get a jet of water, and it strikes the buckets or veins of the runner, and this jet will strikes the buckets or veins or blades of the runner. Okay, so these all are called the buckets or veins. Okay, called a runner. Runner, the main. Okay, so this is the working of a general hydroelectric power plant. Okay, then the main parts of the Pelton turbine are nozzle and flow regulating arrangement. So this is the nozzle, and this with the help of this spear we can regulate the flow. We can increase or decrease the flow. Then run buckets. Okay, so runner and bucket means this rotating part is the runner, and this is called the buckets. This is called the buckets or blades or veins. Okay, that is the second point. Then casing means this is actually all the Pelton wheel is in a case. Okay, so this is called this portion is called a casing. Okay, and the next one is the braking jet, and the fourth one is the braking jet. Okay, so I will explain one by one. So first one is nozzle and flow regulating arrangement. Okay, so the amount of water striking the buckets or veins of the runner is controlled by providing a spear in the nozzle is shown here. You can see this is the nozzle, and here you can see a spear is there. Okay, when the spear is moving in the forward direction, what happens? This will close this nozzle. That's why this flow is reduced, and we can control the speed of the Pelton turbine. If we move this spear in the backward direction, it will increase the flow of water and such that you will get high speed rotation of the runner. Okay, so the spear is a conical needle. You can see the spear. This is the spear. It is a conical needle which is operated either by a hand wheel. So here you can operate using a hand wheel or automatically in an axial direction. This is the axial direction, depending upon the size of the unit. When the pushed forward into the nozzle, so when this spear is in the forward motion, the amount of water striking the runner is reduced. Okay, it will close this opening such that the water level is reduced. Okay, water striking the runner is reduced. On the other hand, if the spear is pushed back, when the spear is actually pushed back, the amount of water this opening will through this opening more water will enter into the runner. Amount of water striking the runner increases. In this way, we can, with the help of this spear, nozzle and flow regulating arrangement, we can control the amount of flow, and we can control the amount of water striking the runner. Okay, so once again I will show. This is you can see this is the nozzle and flow regulating arrangement. This is the nozzle and flow regulating arrangement. Through this spear we can control the flow of water. Okay, and this is the number one, nozzle and flow regulating arrangement. Okay, then the one is the runner and buckets. So you can see in the video this is this rotating part. This is called a runner, and this is the buckets. Okay, runner and buckets. Okay, so I will show you. Okay, so I will show you this. So this video is from actually YouTube. You can search Pelton wheel animation in YouTube. You will get. Okay. So you can see this is the runner. You can see this is the runner, and this is the rotating part, and this is the buckets. You can see this is the buckets. Okay. So runner and buckets. Okay, so figure shows this is the figure. You can see this is the runner and this is the buckets. This is exactly this figure. This is the runner and this is the buckets. Okay, So the runner of a Pelton, it consists of a circular disc on the periphery of which a number of buckets evenly spaced are fixed. Okay, the runner is actually a circular disc and on the periphery of which a number of buckets evenly spaced are fixed. Then the shape of the buckets is of a double hemispherical cup or bowl. Okay, the shape of this buckets, you can see it is not a flat, it is not curved, it is actually the shape of this buckets is actually double hemispherical cup. Okay, you can see two hemisphere, double hemispherical cup or bowl. Then each bucket is divided into two symmetrical parts, okay, by dividing a wall which is known as a splitter. Okay, so each bucket is actually, this is the bucket, this bucket is actually divided by into two symmetrical parts by a dividing wall which is known as splitter. This is called splitter. Okay, then as you show in the video, the jet of water strikes the splitter. Okay, so I will show you this video. You can see this video. Okay, so this is the Pelton turbine. You can see okay, so this is called this is the buckets, this is the bucket, you can see this is the bucket, double hemispherical cup or bowl. Okay, and this is called a splitter, this is called a splitter. Okay, so you can see the jet of water strikes on the splitter. You can see this is the this arrow, this is the jet of water, this is the jet of water that will strikes the splitter. Okay, then the splitter divides the jet into two equal parts. You can see as in the show in the video, you can see this red is the incoming jet and this splitter divides the jet into two equal parts. So this will divide into the jet into two equal parts and the jet comes out at the outer edge of the bucket, and this will comes out at the outer edge of the bucket. You can see this okay, so you can see this is the incoming jet, it will divide into two equal parts and the jet comes out at the outer edge of the bucket. Okay, so this is the hitting of water to the bucket. The buckets are shaped in such a way that the jet gets deflected through 160 degree or 70 degree. So the buckets are actually shaped in such a way that the jet gets deflected through 160 degree or 170 degree. Okay, then these buckets are actually made of cast iron, cast steel, bronze or stainless steel depending upon the head at the inlet of the turbine. Okay, so that is the second point. Okay, so once again this is the bucket, you can see jet of water strikes the splitter and okay, so you can see this is the working. You just go to YouTube and you will get the different videos of Pelton wheel animation. Okay, you can see the runner and bucket is actually rotating when the jet of water hits the buckets. Okay, then the third one is the casing. The next one is the casing. Okay, so casing means actually, so I will show you the casing. Okay, so you can see this is the casing. Okay, so this portion is called a casing. Okay, so the function of the casing is to prevent the splashing of water and to discharge the water to tail race. That is the main function. Okay, it is to prevent the splashing of water and to discharge the water here to the tail race. It also acts as a safeguard against accidents. So this casing will act as a safeguard against accidents. It is made of cast iron or fabricated steel plates. Then the casing of the Pelton wheel does not perform any hydraulic function. This is only a safeguard only. It is only acts as a safeguard against accidents. This casing is does not perform any hydraulic function. There is no other particular function for this casing. Okay. Then the last one is and the fourth one, that is called the braking jet. Okay, so braking jet means when the nozzle is here, I will show you this you can see this thing, this is called the braking jet. Okay, so you can see I will show you a video. Okay, see, you can see this this runner is actually rotating in the counterclockwise direction. Okay, so you can see this runner is actually rotating in the counterclockwise direction. When I apply the braking jet, what happens? When I apply the braking jet, what happens? It will stop the rotation of the runner. So when the nozzle is completely closed, by moving the sphere in the forward direction, the amount of water striking the runner reduces to 0. So when the nozzle is, as I shown in the figure, when the nozzle is moving in the forward direction, what happens? The amount of water striking the runner reduces to 0. Okay, but because of high speed of the runner is rotate high speed due to the inertia, it is actually goes on revolving for a long time. Okay, so I want to stop the runner in a short time. A small nozzle is provided which directs the jet of water on the back of the vanes. So this will so here you can see this jet of water will strike the back side of the vanes. Okay, back side of the this jet of water is called a braking jet. Okay, so this is the main use of this braking jet. To stop the runner in a short time, a small nozzle is provided. So here you can see this is the small nozzle. This is the small nozzle is provided which directs the jet of water on the back of the vane. So here this jet of water strikes into the back side of the vanes. Okay, back side of the vanes. So this jet of water is called a braking jet. I will show you once again. I will show you this. You can see this is the jet of water. This will rotate the runner. You can see I want to stop the rotation for a short while, short time. So you can apply braking jet. Okay, your Pelton wheel will stops. Okay, so this is the overall idea of constructional features of a Pelton turbine. You can once again I will explain. So the marks for this question is 5 marks. Okay, so the one important thing is you have to explain the constructional feature of Pelton turbine. Okay, in a precise manner. Okay, so first you have to explain what is a Pelton wheel. You have to explain what is a Pelton wheel. Pelton wheel is a tangential flow impulse turbine. That is very important. Pelton wheel, okay, is a tangential flow impulse turbine. Then the next important thing is the main parts of the Pelton turbine are 4 main parts: nozzle, runner, casing, bucket, braking jet. Okay, so you have to draw this figure, nozzle with a sphere to regulate the flow. Then you have to draw, not this figure, you have to draw the shape of the bucket. Okay, you have to draw the shape of the bucket, and this figure is very important. 18 point for this figure. Okay, this figure consists of this this casing. You can see this casing, the runner with the buckets, then penstock, nozzle and sphere arrangement, then this jet of water. Okay, you can add another jet of water jet of here, that is called a braking jet. You can add one more pipeline here, and that is called a braking jet. Okay, so this figure is important. Okay, so I hope this is the constructional feature of the turbine. Okay.